In this video, we'll have a look at the product rule. Let's say we have the function fx, and it's 2x minus 1 times x squared plus 3. You can see how the function is a multiple of two other functions. One's a linear and one's a quadratic. And by using the product rule, we can find the derivative of fx. Now, there are multiple ways to do this. You can either expand this out and then use the differentiation rules, or you can use the product rule. And the product rule goes, if fx is a multiple of two functions, let's say ux and vx, then the derivative of f is equal to ux times the derivative of v plus vx times the derivative of x. You just need to memorize that, okay? So going back to our example, our 2x plus 1 will be our u, and x squared plus 3 will be our v. Our first step is to find the derivative of u and v. So the derivative of u, using the differentiation rule, is 2. The derivative of x squared plus 3 is equal to 2x. So we have u, v, and the derivatives of u and v. So now we substitute the values into the formula. First we do u, so 2x minus 1, times the derivative of v, which is 2x. Put 2x at the front. Plus, we have vx, which is x squared plus 3, and we times the derivative of u onto it. It's 2. So that will be the derivative of function x. Now at this step, you need to check if you can factorize the function. Here we can see how 2 is a common factor in both terms, so you group by 2. We get x, 2x minus 1 plus x squared plus 3. Always a good idea to simplify the terms inside the bracket, so that will be 2x squared, so 3x squared minus x plus 3. So that will be the derivative of function f by using the product rule. Or an alternative way is to just expand the brackets. It's easy because there's two brackets and it's all to the power of 1. So we do 3x squared minus x squared plus 6x minus 3. So the derivative of this would be 6x minus 2x plus 6. And if we group it by 2, it becomes 2, 3x. Wait. That should be cubed, 3x cubed minus x squared plus 6x minus 3. So that would be 9x to the power of 2 minus 2x plus 6. Oh, sorry, that should be 2. What am I doing? 2, so that will be 6x. I'll group it by 2, and we get 3x squared minus x plus 3, which is equal to this. Okay. Now, one way they could make the product rule questions harder is by incorporating the chain rule. So, for example, if we had to differentiate y equals x squared plus 2 squared times 4x plus 1, we need to say this is equal to u, and that's v. And when we're trying to find the derivative of u, we need to use the chain rule, as this is to a power of 2. And if you remember the chain rule, we find the derivative, well, we get the derivative of the outside and multiply it by the inside. So we get 2 outside of x squared plus 2 times the derivative of x squared plus 2, which is 2x. So 4x bracket x plus 2 is our derivative for u. Our derivative of v is equal to 4. Yep. Now we repeat the same step. We use the product rule, so the derivative of y is equal to u times the derivative of v plus v times the derivative of u. Substitute, we get x squared plus 2 squared times the derivative of v, which is 4. 4 plus v, which is 4x plus 1 times by the derivative of u, which is 4x 2 plus 2. Okay, now let me rewrite this. That should be 4x at the front. 4x plus 1. There we go, that looks better. So, same step, we factorize first. We see a common factor of 4. So we group it by 4. Get x squared plus 2 on the inside plus x, 4x plus 1, x squared plus 2. Oh, a common factor is actually 4 times x squared plus 2. So this should be 4x squared plus 2 times by x squared plus 2 plus x, 4x plus 1. Now we just need to simplify that. So it should be 5x squared plus x plus 2. And that's how you find the derivative of a function in the form of u times v using the product rule.